Hello everyone, today's day 3 of solving a question from the Neetcode 150 list every day. So today we're going to be doing twosome. I'm going to do something a little different today. I'm just going to go ahead and try to solve the problem. So given an array of integer nums and an integer target, return indices of the two numbers such that they add up to target. So we want to make sure we're return indices. So you may assume that each input would have exactly one solution. You may not don't use the same element twice. You can return the answer in any order, so order doesn't matter. So there's always a solution. So the first test case they give us is, or example I guess, is 2, 7, 11, 15. Target is 9. So it says the output is 0, 1 because index 0 is 2, index 1 is 7, 7 plus 2 is equal to 9. Okay, and it says only one answer will exist. Cool, so the first solution that just like jumps out straight at me is we can have a brute force approach where we just have two nested for loops. It says for I in range. So length nums, for j in range, length nums. So it says that you can't use the same element twice. So if I is equal to j, we just want to continue. So the reason I'm doing this is, for example, if we're here at this one, we don't want to return 0, 0 because that would be adding 3 to itself at the current index. So in cases like that, we want to skip. Otherwise, what we want to do is check if nums I plus nums j is equal to target. And if it is, we just return I and j. Cool. So let's try submitting this. Okay, so the time complexity of this is O of n squared, and the reason why that's the case is because we have two nested for loops, so we gotta loop through the array n times here, then another n times here, so that's n squared. But here, okay, so we have a follow-up here, and it says, can you come up with an algorithm that is less than quadratic time complexity? So let's try doing that. So if we have if we subtract the current value from our target value, this is going to give us the value needed to add to current val to get target. So what I pretty much mean by that is, for example, if we're here at 7, if we subtract 7 minus, if we subtract 9 minus 7, that's equal to 2. And we can see that 2 is already here in the input array. So we know that we'd be able to return 7 and 2 in this case. So pretty much what I'm trying to say is we need a way to store values alongside their indexes that have already appeared. Because if we do that, then we're able to just calculate the value that we need and check if we've already seen it. And the best way to store key value pairs off the top of my head would just be a hash map. So the approach we're going to do is we're going to loop through the array again, and we want to create a dictionary here first. We're going to loop through the array again, and we're going to say we're going to calculate value needed. So value needed is equal to target minus nums I. We say if value needed is if value needed is in values, then we just want to return value needed alongside with I. So pretty much what we'd be doing here is if we find value needed in the values dictionary, that means we've already passed by it and it does exist in the nums array. So we're just going to return the indice where it was found, and we're going to return it alongside the current indice. Otherwise, what we just want to, or the current index, but otherwise what we'd want to just do is values at nums I is equal to value at nums I is equal to I. So we just be adding it back in. Cool. So let's try testing this algorithm out. So we have add array, target is 9, and then let's see, we need values and we need value needed. Cool. So if we start this out, we're starting the for loop. Value needed is target minus nums I is 0, so 9 minus 2, this is 7. We see it's not in values because values is empty right now, so we set nums I is 2. We can set that to 0. So next iteration, we have value needed, current nums I is 7, so this would be 2, so 9 minus 7 is equal to 2. We see that 2 is in the array, so we can return value needed, so value needed is 2, so that would give us 0 and I, so I is currently 1. So yeah, that would be the right answer in this case. Let's try it with the other test case, which is 3, 3, 6. Let's reset all this. So we start the loop. Value needed is equal to target minus nums I. So target is 6, nums I, which is 0. Nums 0 is equal to 3. Values is currently empty. So we just go 3, 0. Then we're in the second iteration, so I is equal to 1. Value needed again is equal to 3. So value needed is in values now. So we want to return values 3, which is 0. And then alongside I, so 0, 1. So that's correct. So yeah, this algorithm should be fine. We don't need to worry about any empty solutions. We don't have to worry about there not being a solution, and we also don't have to worry about duplicate solutions. So runtime error, this object. Ooh, what did I do? List object cannot be interpreted as an integer, line 11. Oh, we got a loop in the range of length nums, not just nums, so that should fix it. All right, perfect. So the time complexity of this is going to be O of n, and the reason why is because we're only looping through the array n times. So it's going to be n iterations is what I mean. And then checking if value needed is in values, that's an O of 1 operation. And adding to the dictionary is O of 1. And grabbing a value from the dictionary is also O of 1. So yeah, the time complexity of this is going to be O of n. And the worst case space complexity is also going to be O of n, since we can possibly store, since there's always going to be a solution, it's going to be at most n minus 1 key value pairs that we're storing in the dictionary. But yeah, so we can just average that out to O of n. So yeah, that's my solution.